Welcome to this demo of our data quality dashboard. This is the main window of our dashboard. On the left side, you have three options to load the input data. In the first option, you can upload the input data CSV files from local storage. And optionally, you can assign an ID number to this data version. The second option is to use one of our preloaded datasets to explore the dashboard without needing to have your own data. For example, if you select the NASA dataset and click the Upload button, the data will be displayed on the Data Overview tab, allowing you to explore the different attributes and navigate through the entire dataset. The third option is to switch to the From Database tab to connect to a SQL database. The dashboard currently supports SQL Server, MySQL, and PostgreSQL databases. In this case, you have to input your credentials and specify the table and dataset to load. Once the data is uploaded and while exploring the dataset, the dashboard automatically generates a profile for each attribute and creates a set of rules called functional dependency rules. Such rules relate the various attributes with each other. In the Data Profile tab, you can see such rules expressed in terms of the determinants and the dependent attributes, along with a confidence score for each rule. Users also can define their own rules by specifying the determinants and the dependent attributes. And users can select and save these functional dependencies to be used later for data cleaning processes. Scrolling down to the dataset properties, you can view statistics such as the number of variables, rows, missing values, data size, data types in terms of how many text, categorical, and numerical attributes, and detailed metadata for each attribute. Let's select sound pressure level can be obtained, like distribution, distinct values, mean, and maximum values. Additional statistics can also be obtained, like different quartiles, and showing the histograms and the most common values, and extreme values like the minimum 10 values and maximum 10 values. Also, user can get information about the correlation and interaction between the different attributes. After understanding the input data, we can return to the Data Overview tab to start the data cleaning process. Before running any data cleaning tool, users can exploit their exploration of the data to tag known corrupted data samples. For example, here, this value .0088 is known to be dirty, so users can simply enter this value here and press enter, and this value will be added to the list of detections. To run external data cleaning tools, users have two options. The first option is called cleaning tools, and the second one is called iterative cleaning. Let's start with the first one. And the first one, users can select from a set of external tools, and the dashboard is connected to several detection tools, different in their complexity and error types that they can detect. This means some of these error detection tools can be better than other tools. For higher accuracy, users can choose multiple tools like ST, which is standard deviation, isolation forest, for example, and FAS. Detected values, which will be obtained after clicking on the Detect Errors button, will be displayed and highlighted in red in the Data Overview tab. This could take some seconds before showing the results, and here the dashboard is updating, which means that there's process already going on in the background. As you can see here, the detected values is highlighted in red, and we have the option to only show dirty rows. And the dashboard here visualizes the distribution of dirty and clean data. And also in the detection results tab, we can get a more detailed overview by showing or by visualizing the distribution of detected errors across different attributes. And also here we can get the error types like the outliers, the missing values, and the errors tagged by the user. The dashboard also supports machine learning based error detection tools like Raha. So we can select it from the list here. To use this tool, we have to label some tuples as dirty or clean to train a classifier that detects errors. So if we click on the Detect Errors button, so dashboard will ask for the labeling budget, which is how many labels the user is willing to label. So for now, let's consider 3 and press on the Detect Errors button again. And here the dashboard will show some tuples where the user has to find whether we have errors here or not. So we have a missing value here, so we can submit this value. And for the next tuple, we may have or we may not have errors, so we can skip this one. And yeah, here also we don't have, it seems that we don't have any errors. We have here an error in the angle attribute. We can submit this one. And for the next one, we don't have errors. And let's assume that here we have error in that velocity attribute. So once we submit, the classifier will be trained, and the detection classifier of Raha will detect errors. As you can see here, it is visualized as before. And it's important to know that providing more labels improves the detection accuracy. The next step is to pick an error repair method. And currently the dashboard supports two types. The first one is called standard imputer, which replaces errors with the mean value in each attribute, and machine learning imputers that trains a machine learning models to generate the repair candidate. For this demo, let's select the machine learning imputer and click on the repair errors button, and within a few seconds the results will be posted here, where the repaired version of the data is saved successfully at this location. Before delving into iterative cleaning, which is the second option, let's explore another feature, which is generating data sheets. In the datasheet tab, click Generate button to create a JSON document listing information about the input data, including locations of different data versions and the executed cleaning tools and their configuration. We can give a name to this document and download it for replicating the data cleaning process later, enhancing reproducibility. In the Load Datasheet tab, you can specify one of the existing data sheets, and it will be loaded automatically. And this gives you the ability to load existing data sheets to review data preparation steps done so far. The last feature is iterative cleaning, where the dashboard selects the best cleaning tools for your dataset to improve downstream machine learning model performance. In iterative cleaning tab, the dashboard creates cleaning tools as hyperparameters adjusted during the training using a Bayesian-based method called Optuna. Let's go to this tab and select the model that you want to train. Let's for now select decision tree, but also you have option to select neural network or random forest. And the user has to define which or how many number of search iterations we can go through, and cross validation. And let's for now select 50 training epochs. Once we click on the Run Iterative Cleaning button, it will ask us to label some data in order to run Raha. So now we submit this one, and now in the background, it is estimating the error or executing the error tools. And after execution, it will post it here, or the results will show the chosen tools. And as you can see here, in the repair is successful, and best cleaning tool is for error detection, it's Raha, and for repair method, it's standard imputer, and these results are specifically for this dataset under these configurations. And also we can see the mean square error and mean absolute error and R square. And that's an overview of our data quality dashboard. Thank you for watching.